Hello, everyone, and welcome to your video, which is going to be talking about how to convert from degrees into radians and vice versa, from radians into degrees. We're going to talk about both of those things in this video. And so before we get started dealing with degrees and radians, let's just have a quick review on what it's like to convert things generally. So let's say that I want to convert 3.56 feet and I want to convert that into inches. You might remember us doing this in the past. We can turn this into a fraction, and then we need to multiply it by some conversion factor. And this can be any conversion factor that is both helpful and true. So since we're going into inches, I'm going to do 1 foot equals 12 inches. And that's going to be my conversion factor. Notice that my feet start in the numerator here, and then they move to the denominator into my conversion factor. And that diagonal movement is what we want to see always when we are converting things. So now we just do this math. I whip out my handy dandy calculator and I do 3.56. Oops, gotta hit the right number. 56. Oops. Times 12. Oops. Times 12 is 42.72 inches. And so we've converted. Now I can make the conversion even harder by having us do more steps. For instance, if I did 10.4 decades and I wanted to convert that into hours, how would I do that? Well, I would just do a series of conversion fractions. So here we have decades. So I want decades in the bottom here. If you want, some people like to see all fractions going across. It just makes them feel good. So you can do that if you want to. So what do I know about decades versus anything that gets me closer to hours? Well, I know that 1 decade is 10 years. Okay, and then what do I know? Well, I know that 1 year is 365 days. And I know there's really a 0.25 in there because of leap year, but I'm ignoring that because I want to. And then I know that 1 day is 24 hours. So now I have a series of conversion factors. And if I whip out my handy dandy calculator, I can calculate, let me see, 10.4 times 10 times 365 times 24 equals 911040. That is how many hours are in 10.4 decades. So that's the gist of what we're going to do. But we're going to start applying it now to degrees and radians. So let's just start with 45 degrees, and we want to convert that into radians. I would like to point out that you probably, maybe, might already know the answer to this. Let's draw ourselves a picture. So here we have 0 degrees. Here we have 180 degrees, right? If you went halfway around the circle, that would be 180 degrees. Half of that would be 90 degrees, and half of that would be 45 degrees. Are you with me? Okay. Now, let's convert that into radians. This, if you went all the way around the circle, would be 2 pi radians. So halfway around the circle is going to be pi radians. 90 degrees is going to be half of pi, so that's pi over 2. And 45 degrees is going to be half of pi over 2, which is pi over 4. Again, 1, 2, 3, if you can imagine a little thing here, 3, 4. You would have 4 segments to get you to 180. So we already know that the answer should be pi over 4. Let's figure out how to get it using this technique. So I'm going to put here some conversion factor that I find A, helpful, and B, know to be true. And that conversion factor that I'm going to use is 360 degrees is the same thing as 2 pi radians. So that is my conversion factor. And if I do that, and I do this math, I get 90 pi on top and 360 on the bottom. But just like always in math with fractions, it has to be in lowest terms. So this is 1 pi, or just pi, over 4. So 45 degrees is the same as pi over 4 radians, which is, by the way, exactly what we got when we just did it visually like this. Now, before we move on, I would just like to point out that I could have done this problem a little bit differently. I could have started with 45 degrees, but instead of using 2 pi to 360 degrees as my conversion factor, I could pick a different conversion factor. Maybe I want to pick, well, I know that 180 degrees is just plain pi. So I could do pi over 180. And when I do that math, I get 45 pi over 180. And then can't be lazy, still have to reduce into pi over 4. So you get the same answer regardless of which conversion factor you use. As long as your conversion factor is a valid conversion factor, then you're good to go. All right, so now let's practice with some harder ones. And the reason that it's harder is simply because we probably can't just visualize it in our head like we could with 45 degrees. So let's do, for instance, let's do 15 degrees. Okay, what is that in terms of radians? Well, I'm going to do 180 degrees is the same thing as pi radians. So I will do 15 pi over 180. And I'm pretty sure I'm going to be able to reduce that. Let's just see if I can reduce completely. 180 divided by 15. Can I do that? 12. Great. So that's going to be pi over 12. That is radians. This is degrees. And again, just so you can visualize, we're not going to do this every time, but just so you can visualize, 15 degrees would be like this. And we would be able to fit 12 of them going around to our 180 degree mark. And then 12 more coming back this way. Pi divided by 12. 12 of them would fit here. Okay. Let's do one more. Let's do a big one. Let's do 297 degrees. So on our circle, let me see, this is 270 degrees. If I go 3/4 of the way around, that's 360 degrees. So I'm going to call that about right here, 297 degrees. What is that in terms of radians? Well, I'm going to multiply it, and this time I'm going to be crazy, and I'm going to use this. I'm going to say, well, I know that 2 pi is 360 degrees. Now, you might not like this method because you might say, Mr. Lisi, the numbers get so big when you use this. Yeah, well, what can I say? I'm just feeling wild. So that's 594 pi on top divided by 360. And this is going to take quite a bit of work to reduce, and I don't feel like working hard. So I'm just going to divide the top and the bottom by 2. So now I have 297 pi over 180. And then do you think 297 is divisible by 3? Wouldn't that be nice? Oh, it is. So let's do 99 pi over 60. And then I think I can divide by 3 again, which would give me 33 pi over 20. Does that look right? That does look right. And now I think I'm done because I can't think of a number that goes into both 33 and 20. So that is my final answer. Yeah, it's ugly, but it is correct. All right, let's try it going the other way. So this time, instead of starting with degrees, let's start with the radians. So let's say I have 6 pi over 7 radians. 6 pi over 7. I want to convert that into um uh what am I converting into? I'm converting into degrees. That's what I'm converting into. So what do I know? Well, I know pi degrees or pi radians is the same as 180 degrees. So I could set it up like this. All right, let's do it. So I have 6 pi times 180. So that's 6 times 180 is 1080 pi on the top, and then I have 7 pi on the bottom. My pi's cancel out, so now I just have 1080 over 7. And if I do that math, do I get anything nice? No, I get 154. Well, I'll round it for you. 154.29 degrees. Yeah, since I made that up in my head, it didn't work out very nicely, did it? Yeah, but that's okay. It's still accurate. Okay, let's do another one. I'll do an easier one. Let's say that I wanted to calculate 4 pi and I want to convert that in degrees. Okay, before we do it, I want you to think about it. And maybe you have a guess doing a little bit of mental math. Do you? 1 times around the circle is 2 pi. So 2 times around the circle would be 4 pi. And 2 times around the circle would be how many degrees? Huh, I don't know. Let's figure it out. So we're going to put our pi down here and our 180 up here. And we are going to do math. So 4 times 180 is 720 pi. There's still a pi on the bottom here because 1 times pi is pi. My pi's cancel out, so I get 720 degrees. Is that what you thought when you did your mental math? If so, give yourself a gold star. If not, just take another swig of Diet Coke. I'm sure you'll get it next time. All right, that's about it for today. I hope that you feel comfortable converting backwards and forwards from degrees to radians.